Hello students. Today we are starting about chemical reaction. So first, uh, so first we are starting what is the meaning of chemical reactions. Now, if we are taking simple example, for example, if we are having a magnesium ribbon and when this magnesium ribbon react with oxygen which is present in air, now after the reaction for some heating, it gives a new compound that is called magnesium oxide. Now, when we are taking this experiment or this reaction, then we are taking initially magnesium and oxygen, but after the experiment or after the reaction, we are having a magnesium oxide. Now, in these two sides, that is that is the right side of arrow and that is the left side of arrow. When we are discussing left side, then we are having magnesium and we are having oxygen, and in the right side we are having magnesium oxide. When we are discussing the properties of magnesium, suppose that is X and the properties of uh, this oxygen that is Y. We are seeing that property about the chemical properties. Now, when we are dealing the property of magnesium oxide, that will be Z. So we are saying that if the right hand side compound that we also call product having entirely different properties that we from X and Y, then this types of changes is called chemical change. And when these types of changes return in the equation form, that we call chemical equation or chemical reactions. So simply we can say that chemical reaction means when we are obtaining a new substance that's property is entirely different from the initial compounds or initial reactant. So first we are discussing some interesting thing or interesting fact about chemical reaction. The most interest, the most interesting thing about the chemical reaction is that each and every chemical reaction, that is the essential condition, that is the during the chemical reaction that we compulsory change in the heat or change in the energy. Change of the energy that is represented by delta H. Delta H, here is the delta S sign is the change and H for the enthalpy. So basically delta S means change in enthalpy, and here is the enthalpy is related to the heat or energy. Now each and in every chemical reaction it should be compulsory that delta H equals to 0. It's never possible. In every chemical reaction there will be two possibility, that is delta H either positive or delta H either negative. Now how we can calculate the value of delta H? This delta H, it will be equals to Hp minus Hr. Hp, it is the heat of product minus Hr, it is the heat of reactant. Now if we are assuming that heat of the reactant is greater than heat of the product, it means Hr is greater than Hp, then at this situation the value of delta H comes out to be negative. And if delta H value will be negative, then no doubt the reaction will be exothermic. The reactant H having higher energy level, then reaction will be exothermic. And if we are considering that delta H equals to Hp minus Hr, then we are saying that Hp is greater than Hr, then at this situation delta H must be positive and the reaction will be endothermic. Now these two things explain by the help of a graph. Suppose this is the graph. Here in this axis we are taking reaction coordinate RC, means progress of reaction. Now this vertical axis represent potential energy. Now we are taking simply, here is the reactant, that is R. Next line for the product. So we are taking the product line upon this side. Suppose this one is the product. Now this one is the energy of reactant and this one is the energy of product. Now the energy difference between reactant and product, that will be called delta H. Now according to this graph, the energy of product is greater than energy of reactant. So if we are simply written the reaction, that is N2 plus O2, it gives a product nitric oxide, that will be 2NO. Now this reaction performing when we are heating of this. So obviously that is the N2 and O2, here is the reactant, and nitric oxide, that will be the product. This changes will be performed when we are heating N2 and O2. So obviously we are supplying the some amount of heat for the N2 and O2, then absorbing the heat, some amount of heat, they will be converted into nitric oxide. So obviously the amount of extra heat is absorbed by this nitric oxide. So we can see that in that case, energy of the product is greater than energy of reactant. It means this changes happen when we are supplying the some amount of heat. So we can say that for the performing of this change, the energy must be supplied. So we can say that this reaction is endothermic. Means endothermic reaction means reactions, chemical reactions or changes which will be performed by the absorbing of heat energy. And for that, delta H becomes HP minus HR. In that case, HP is greater than HR. So delta H must be. Now, in that graph, when first reactant absorbing some amount of heat and go up a hill, this hill. This hill is also called transition state or intermediate, since it is not possible that reactant directly converted into product. First, reactant goes up a high energy level, then the high energy level product or high energy level state, it is called TS or transition state, that will be converted into product. The energy difference between the reactant and transition state is also called activation energy and simply represented by EACT, that will be called activation energy. Now in that case, the overall reaction will be called endothermic reaction and the graph is called reaction coordinate endothermic graph. Now we will about exothermic reaction. We are simply taking another graph that's type, and here we also written reaction coordinate, and in this axis we are writing the potential energy. Now this line is for reactant and this comes for product. Now the energy difference between these two is called delta H. According to this graph, here is the HR is greater than HP, therefore delta H will be negative. Now first reactant reaching up a high energy hill and that will be converted after product. This higher energy hill is called TS, transition state or reaction intermediate. In the transition state, the new bond is not completely formed and the old one is not completely break up. For example, if we are taking the simply AB plus CD and after the reaction we are having the product of AC plus BD. But this change is not directly happened. Actually what will happen first this AB bond break up partially and the CD bond also break up partially, and then we are demanding that the formation of new bond between A and C and also forming the new bond between B and D, but the formation is not completely, it will be again partially. So here is the partial bond formation AC and the partial bond formation between BD, and after this change the product will be formed. So this is called TS, transition state or intermediate. Now this overall change is called exothermic reaction. So now no doubt we can say that in exothermic reaction, reactant at higher energy level and product at lower energy level. So generally we can say that generally exothermic reaction may be spontaneous, though although it's not always true, but simply we can say that exothermic reaction is generally spontaneous, since as we all are know that if the compound is the lower energy state, that will be stable. But since in exothermic reaction the product will be at lower energy level. So in exothermic reaction, no doubt product is more stable as compared to reactant. So that's why we can say that exothermic reaction sometimes or generally may be spontaneous, but it's not always 100% true. Sometimes it may be happen that exothermic reaction is also non-spontaneous. For example, we are taking the example of magnesium ribbon, that is Mg plus O2, that gives magnesium oxide. Although it's an exothermic reaction, but it's not a spontaneous. Some for starting the reaction, we are starting initially heating, then after heating it gives a magnesium oxide and a large amount of heat. So in that case, the given amount of heat is less than the releasing amount of heat. So no doubt the overall reaction will be exothermic, but this reaction is not spontaneous. Spontaneous means the reaction is performed by automatic without driving any force. But we can't say that this reaction is spontaneous, since in this reaction we are starting the reaction by the applying of temperature. So this reaction is not exothermic reaction. Sorry, this reaction is not a spontaneous reaction, but in overall changes, the amount of heat released. So this is the spontaneous exothermic. So this is the non-spontaneous exothermic reaction.